Hi, welcome back to my channel pibyme Maths. This is by WST02. Here we are solving May-June 2022 Statistics 2 paper. And in the previous video we have covered question number 1, 2 and 3. Let's look at question number 4. Past evidence shows that 7% of pears grown by a farmer are unfit for sale. Okay, 7%, it can be a probability of success or failure depending on the question. This season it is believed that the proportion of pears that are unfit for sale has decreased. Okay, decreased. To test this belief, a random sample of n pears is taken. So we have n. So we can say x follows binomial distribution of n, 0.07. The random variable y represents, okay, we use y, not x. Y represents the number of pears in the sample that are unfit for sale. Okay, find the smallest positive value of n such that y is equal to 0 lies in the critical region. If it lies in the critical region, when you find the probability, it should be smaller than the significant level. That's what this means. Okay, for this binomial distribution, p of y is 0 is nc0 p to the power 0 times q is 1 minus p, 0.93 to the power n minus 0 is less than this, and make n as a subject. nc0 is 1, anything power 0 is 1, so you have only this inequality. Take logarithm, n log 0.93 is less than log 0.05. Log 0.93 is a negative number, so when you divide you need to flip the sign. Over log 0.93. Get the value now. Log 0.93 is a negative number, so log 0.05 over this is 41.28. We are not rounding the figure, we need to take the next integer, therefore n is equal to 42. That's all. 3 mark question. Let's move on to part B now. Part B says, in the past, 8% of the pears grown by the farmer weigh more than 180 grams. Okay, now it's 8%. This season, the farmer believes that the proportion of pears weighing more than 180 grams has changed. So before it was P is equal to this. Now P has changed actually. They did not say reduced or increased. She takes a random sample of 75 pears and finds that 11 of them, that's the observed value, weigh more than 180. Every word is important. If they say 11 of them weighs less than 180, you need to check 75 minus, you need to take 75 minus 11, which is 64 weighs more than 180. That's why you need to read the question carefully, word by word. Okay. Test using a suitable approximation whether there is evidence that the proportion of pears weighing more than 180, there is a change in this. You should use this significant level and state your hypothesis clearly. Hypothesis H0 is, null hypothesis is P is 0.08. Alternative hypothesis is P is not equal to 0.08. And n is equal to 75. You write, assume that H0 is true. So you can write x follows binomial distribution of 75, 0.08. To apply Pearson approximation, lambda is equal to np is 75 times 0.08. 75 times 0.08. That's 6. Therefore, J follows, I'm going to use another variable, Pearson distribution of 6. Now the observed value is 11, right? It's a two-tailed test. So always remember this. If the observed value observed value is greater than NP, you need to take x is greater than or equal to x. If the observed value is less than NP, you need to take lower tail test actually. Always remember that. The NP is 6, observed value is 11. You need to write 11 is greater than 6. Therefore, P of x is greater than or equal to 11. You need to calculate this, which is 1 minus P of less than 11 or less than or equal to 10. So I'm going to use a calculator to find this. Go to distribution, number 3, pause on CD, number 3, 2, we don't need the list, x value is 10, the lambda, the mu is 6, we got it already. So you write 1 minus 0.9573 dot 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 and write the final answer. Yep, okay. Minus 1. 0.0426. 0426 to 3 significant figure. Okay. Let me go to the next slide to explain this. So we got the probability P of x is greater than or equal to 11 is 0.0426. You need to divide the significant level by 2 because it's a two-tailed test. Don't forget to divide by 2. So 0.025, this is bigger than 0.025. So do not reject H0. Always remember the condition. When your calculated value is less than the significant level or observed value lies in CR, critical region, reject H0. This is the only condition you should remember. Okay. If it's not, do not reject H0. Here the calculated value is bigger than the significant level, so do not reject H0. That means we are accepting this, we reject this. So how do we write the conclusion? We need to write, so how do we write the conclusion? We are rejecting this, so you need to write there is insufficient evidence to suggest that there is a change in the proportion of pairs weighing more than 180 kg. Just need to write that. You need to write the conclusion, otherwise you will lose more. Question number 5 now. The number of particles per milliliter in a solution is modeled by Poisson distribution with mean this. Okay. Randomly select, do not take it as lambda first, because it's per milliliter, but the question talks about a randomly selected 50 milliliter. So you need to multiply 0.15 by 50 to find lambda. That's going to be 0.15 times 50, 7.5. So you can say x follows Poisson distribution of 7.5. Find the probability. Exactly 10 particles found. So that's going to be e power minus lambda, lambda power 10 over 10 factorial, and then double I between 6 and 11 inclusive. So 6 is less than or equal to x is less than or equal to 11 is same as x is less than or equal to 11 minus we need 6. So we subtract till 5. So for 7.5 we are going to get the table values here. Let's calculate this one first. E to the power minus 7.5 times 7.5 to the power 10 over 10 factorial. 0.8583, 0.08583 dot dot dot. You can round it to 3 significant figures. And here I'm going to use a table value for double I. For lambda is equal to 7.5, x is equal to 11 and 5. So lambda is 7.5 is this one. We need the value for x is equal to 11 and 5. So when x is equal to 11, it's 9208 here. 0.9208 minus, for x is equal to 5, it's 2414. 0.2414. So 0.9208 minus 0.2414. 6794. 0.6794. That's the answer. Let's move on to part B now. Petra takes 12 independent sample of m milliliters of the solution. So there are 1.5 particles per milliliter. So for m milliliter, this is times m, right? Okay. The probability that at least 2 of these samples, they want us to find at least 2 out of 12. That's binomial distribution. But what is the probability of success here? The probability that they contains no particle. That's a probability of success. So here, let's say y follows Pearson distribution of 0.15 m. First we need to find y is equal to 0, which is e power minus lambda times lambda power 0 by 0 factorial. This is the probability of success now. So n is 12. Probability of success is e to the power minus 0.15 m. Now we use another variable. M follows binomial distribution of 12 comma e to the power minus 0.15 m. So in this binomial distribution, when you find the probability that at least 2 p of m is greater than 2, or this probability is given, you can write m is greater than 2, at least 2 greater than or equal to 2 is same as P1 minus P of m is less than 2 or less than or equal to 1, right? If you rearrange it, P of m is less than or equal to 1 is going to be 1 minus this value, 0.8816. Now let me copy this whole thing. Now I'm going to use the binomial distribution table for n is equal to 12, x is equal to 1, and for what value of p I am getting this. So that value is the probability of success. Understand? N is equal to 12, x is equal to 1. Let me open the table for binomial. N is equal to 12. X is equal to 1. We have all these values for x is equal to 1, but we need to look for 8816. 8816 is in here, where the probability is 0.05. So that means this probability is 0.05, right? So you need to write from table p is 0.05. So equate this to 0.05 and make m as a subject. So if you remove e, minus 0.15 m is ln 0.05 and m is equal to, you divide this by minus 0.05. ln 0.05 divided by minus 0.15. Get 19.971, etc. So m is equal to 20. That's the answer. Question number 6 now. We have a PDF function of a continuous random variable is given. It is shown that p of x is less than 4 is 31 over 45. Find the value of k. How do we find x is the probability from x is less than 4? You need to integrate this and this, right? So this means basically 0 to 2.1x dx plus 2 to 4, the second function, k x times 8 minus x dx is equal to 31 over 45. Integrate, sub in the limits and make k as a subject. So when you integrate the first one, It's 0.1 times x square over 2. 0 to 2. Plus keep k outside. When you open the bracket, it's 8x. So when you integrate 8x square over 2 minus x square becomes x cube over 3. 2 to 4 is 31 over 45. We need to simplify this and find the value of k. So here, move the equation here. When you sub in the upper limit here, that's going to be 4 over 2 is 2 times 0.1 is 0.2. Lower limit, you sub in lower limit, everything is 0, leave it. Plus k times, sub in the upper limit, 4 square, 8 times, maybe we'll write one more step. 8 over 2 is 4 times 4 square minus 4 cube over 3. That's upper limit. Minus. When you sub in lower limit, 8 over 2 is 4 times 2 square minus 2 cube over 3 is 31 over 45. Let's calculate this now. 4 times 4 square is 4 cube minus 4 cube over 3. 128 over 3 minus, calculate this now. 4 times 2 square is 16 minus 2 cube is 8 over 3. That's 40 over 3 times k is equal to 31 minus 45 minus 0.2. So this is basically 88 over 3. 128 minus 40. 88 over 3 k times is equal to some value, make k as a subject. 31 over 45 minus 0.2 times 3 over 88. So you can straight away write k is 1 over 60. It's a 4-mark question. That's all now. Let's move on to part B. Okay, I have copied the function here. Part B, I find the value of a. Okay. We know the total integral 0 to 2 f of x dx plus integral 2 to 4 f of x dx plus integral 4 to 6 f of x dx. It should be equal to 1, right? Because it's a PDF function. We know this already from part A. This is p of x is less than 4, right? And it's given us 31 over 45. So sub in here 31 over 45 plus integral 4 to 6, the f of x is a dx is 1. So when you integrate a, it's just ax, the lower limit, upper limit. You bring this number here, 1 minus 31 over 45 is 14 over 45. So you sub in upper limit 6a, lower limit 4a, so you will get 2a is 14 over 45. A is, when you divide by 2, you will get 7 over 45. That's the value of a. Now for double I, they want you to find the probability from 0 to 5.5. So basically we need to integrate the function from 0 to 2, 2 to 4, 4 to 5.5 and get the value. We know this probability is 31 over 45 plus integral 4 to 5, 4 to 5.5. f of x is a dx. You can sub in the value of a here. 31 over 45 plus a is 7 over 45 from the previous part. When you integrate, you will get x4 to 5.5. When you sub in the upper limit 5.5, lower limit 4, just calculate this now. So it's 31 over 45 plus 7 over 45 times 5.5 minus 4 is 1.5. 83 over 90 is the answer. That's all. It's total of 3 marks. This plus this I and double I together is a 3-mark question. Let's move on to part C. Specify fully cumulative distribution function. let me put this f of x here. We need to integrate them one by one. First one, when you integrate the first function 0.1 dx, you will get 0.1 x square by 2 plus c. Use the condition f of 0 is 0. This is a lower limit, so you can use this condition. When it comes to the third one, you use this condition f of 6 is. So when you sub in f of 0 is 0, you will get 0 is 0 plus c is 0. So f of x is just 0.1 divided by 2x square, which is 0.05 x square. That's the first f of x. And let's find the second one now. This one. We know the value of k here, right? 1 over 60. Okay. So f of x is integral 1 over 60. I'm going to keep it here, k. X times 8 minus x dx. So that's going to be 1 over 60. 8x square by 2 minus x cube over 3 plus c. We need a condition here, right, to sub in so that we can find c. If you sub in 2 here, we know f of, sorry, not 2 here, 2 here. This is the limit for this. When you sub in 2 here, we'll get f of 2 is equal to 0.05 times 2 square. 0.05 times 2 square is 1 over 2. 0.2. So we are going to use this condition here. 0.2 is equal to 1 over 60 times, replace x by 2. So 4 times x square minus x cube over 3 plus c, get the value of c. This is another way of finding f of x. Or if you want, you can integrate f of x from 0 to 2, the first function, and then just put 2 to x, the second function dx. You will get f of x also. So here the c is going to be 0.2 minus 1 over 60 times 4 4s are 16 minus 8 over 3 minus 1 over 45. So c is minus 1 over 45. So I'm going to write the f of x now. So for this, the f of x is 1 over 60 times 4x square minus x cube over 3 plus c. And then now the third one. This one, when you integrate, capital F of x is equal to integral a dx is ax plus c. Sub in the condition f of 6 is 1. So 1 is equal to 6a plus c. C is 1 minus 6a. We know the value of a here, right? A is 7 over 45. So sub in 1 minus 6 times 7 over 45. Get 1 over 15. So f of x is ax plus 1 over 15. Now using all the capital F of x, we need to write the function now finally. Okay, the first one is, where is it? It's here. 0.05 x square. So write 0.05 x square. The second one is in here, this one. So 1 over 60 times 4x square minus x cube over 3 minus 1 over 45. And the third one is this. Don't put a, you need to use the value of a, which is 7 over 45x plus 1 over 15. You need to write the limits, the limits given in the f of x, the same limits, 0 to 2, 2 to 4, 4 to 6. 0 to 2, 2 to 4 with the same symbols, 4 to 6, 0 you put it as x is less than 0, 1 you put it as x is greater than 6. This is capital F of x. You need to write this at the end. That's capital F of X. Question number 7 now. A bag contains 10 counters, each with exactly one number written on it. There are 6 counters with number 7. So P of number 7 is 6 over the total. 3 counters with number 8. P of 8 is 3 over 10. 1 counter with number 9. P of number 9 is 1 over 10. Total probability is 1. Okay. A random sample of 3 counters is taken from the bag without replacement. That means when you take one counter, you are not going to put the counter back into the bag. So when you take the second counter, the total count will be down by 1. From 10 it becomes 9 and 8, 7 and all. That's what this thing means. These counters are then put back in the bag. Wait, what? A random sample of 3 counters is taken from the bag without replacement. Oh, without replacement they are taking 3. That means they are taking 1. They are holding it. They are not going to put it into the bag, and then they are taking the second counter and then the third counter. So it's considered one draw actually. So once one draw is drawn, they are going to put all 3 back into the bag and they are doing it again. This process is repeated until 20 times. The random variable y represents the number of these 20 samples that contain, n is equal to 20 here. The probability of success is a sample that contains the number counter with the number 9 on it. That's the probability of success. So you are taking 3 counters and you have to have a counter with the number 9 on it. You cannot say at least one, because all you have is just one counter with number 9 in it. So I'm going to write all the combinations now first. We are taking 3 counters, but you should have a counter with the 9 in it. So it can be 9, 7, 7, or all the 3 combinations of this. 7, 9, 7. Second counter taken can be 7, or the third counter can be 9. Second counter can be 9. And then 9, 7, 8. Or put the 9 in the middle. Put the 9 at the last. Or 9, 8, 7. Or put the 9 in the middle. Or 9 at the end. Or it can be 9, 8, 8. 8, 9, 8. 8, 8, 9. That's all. We have taken all the combinations already, right? So it's basically a similar combination times 3, right? Total of 12 combinations. So we need to find the probability of this. That's considered the probability of success. So the probability is, you can take the probability of this multiplied by 3. So 3 times, by taking 9, the probability is 1 over 10. Taking 7, there are 7 counters. So 6 over, total count is 9 now. When you take the third one, it's going to be 5 over 8. Because you are taking 7 again. Plus this one now. These two are the same actually. So instead of writing it as 3 times, we can write it as 6 times. First we are taking 9. And we are taking 7 and we are taking 8. There are 3 8 counters with the number 8 on it. So 3 over 8 actually. Why 8? Because every time when we take 1, the count is down by 1. Plus this one now. 3 times 1 over 10. We are taking 8. So 3 over 9, 2 over 9. We need to calculate this. For all these terms, we have 3 terms actually. This is the first term, second term, third term. For all these 3 terms, the denominator is 10 times 9 times 8. 10 times 9 times 8 is the denominator. So we can put it as a single fraction. 365 in the first term. 365 plus 663 plus 332. You get the answer 3 over 10 now. 3 over 10. That's not the answer. That's the probability of success now. Let's go back to the question. We know n is 20, probability of success is 3 over 10. So we take it as binomial distribution for y. Y follows binomial distribution of 20, 3 over 10. And then we can find mean and variance. For mean, the formula is NP, which is 20 times 3 over 10 is 6. For variance, it's NPQ, which is 20 times P is 3 over 10, Q is going to be 7 over 10. So it's basically 6 times 7 over 10. 4.2. That's all. We got the mean and variance. Let's move on to part B now. A random sample of 3 counters is chosen from the bag, again without replacement. List all the possible samples where the median of the numbers is 7. Okay, the median, the middle number, if you put them in ascending order, 7. If you want to have median as 7, you have to have 2 7s in it. Right? Then only you will. If you take 7, 8, 9, the median is 8. You cannot take it. So you need to have 2 7s in it. Right? So you can take all the 3 combinations of this. Or it can be 7, 7, 9 also, right? Still the median is 7. Don't think the median is 9 here. You find the median after writing them in ascending order actually. So 9, 7, 7. Is there any other combination? You can have all 3 7 also, right? So these are all the possible samples where the median of 3 numbers is 7. That's all. Just a 2 mark question. Part C. Find the sampling distribution of the median of 3 numbers. Now we got all the combinations where the median is 7, right? So we can straight away find P of M is equal to 7 first. Okay, I'm going to copy the combinations first. Let me put the combinations here for easy reference. The first 3, right, you can write it as 3 times. You are taking 7. How many 7s are there? 6 actually. So 6 over 10, 5 over 9 and 1 8, which is 3 over 8. So we got these 3 combinations. They are over. And the next one plus again 3 similar combination. 3 times 6 over 10, 5 over 9, 9, there is only 1 9. This is also over. Plus 7, 6 over 10, 5 over 9, 4 over 8, because we are taking all 3 7. Let's calculate this probability first. Again here the same denominator, we have 10 times 9 times 8. So the numerator is the first one, 3 times 6 times 5 times 3 plus 3 times 6 times 5 plus 6 times 5 times 4. That's probability 2 over 3. So what are the other median number you can get? You can get median 8, right? Okay. I have copied the combinations with median 7. The same way you can get median 8 if you replace all this 7 by 8, 8 by 7. This will give you median 8, right? Or all 3 8 also. All 3 8 also. We need to calculate this. Is there any other median you can get? 7, 8. Can you get number 9? There is no way we are going to get number 9 as the median, because to get number 9 as the median, you need to have 2 9s actually, but the question clearly says there is only 1 counter with number 9 in it. So there is no way you're going to take 2 counters from the back. So the median cannot be 9. It's just only 7 or 8. So for 8, you don't have to calculate the whole thing. You can just put 1 minus this, which is 1 over 3, and then write the probability distribution table. Small m, P of capital M is equal to small m The values are 7 and 8, 2/3 and 1/3. That's all.